we're going to look at solving logarithmic equations. In a sense, we've been building up to this point in the last several videos. The log equation is going to be an equation where x is trapped inside the log, so x is part of the input for the log. Our goal is to solve for that x value that makes the statement true, that balances out the equation. So our first step is a very familiar first step. Our first step is to condense. So we've talked about using log properties to condense. We want to condense into log form, and we've talked about log form already as well. Condensing into log form means we want the log, we want the base, and we want the input. So we want to have only these things by themselves on one side. So we want only one log, one base, one input, and nothing else in front of the log or behind the log except those things. On the other side, we'll have the exponent. So we want to condense the equation into this log form. The next step is also something familiar. Anytime that we want to solve a log, we're going to rewrite into exponential form. Okay, we've done that before as well. As soon as we rewrite into exponential form, then we're going to solve for the variable, and then we're going to check our answer in the equation. We do want to make sure that the input, or the domain, is always greater than 0. So for logs, one of our rules was that the domain is always from 0 to infinity, not including 0. So we're going to make sure that the input for every log, when we go back and check our answer, is always greater than 0. Alright, so let's look at using these steps to solve example 1. So example 1, we want log form. So that means I want to be able to look at this equation and say, on one side I have log, the word log, I have a base, I have input, and on the other side I have an exponent. Okay, well, when I look at this, I have the word log, I have the base, I have the input, and equals, so check, 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 and then I have a number on the other side, that's the exponent. So step 1 is actually already done for us. Okay, let's look at step 2. Step 2 then says to take that and rewrite that into exponential form. So in order to rewrite into exponential form, okay, let's do it this. Log form was step 1. There we go. That was really already done for us. Step 2 is exponential form. And this is something that we'll actually have to do. We're going to identify what is the base, what is the input of the log, and what is the exponent. The base of the log is 4. The input for the log is x plus 3. The exponent here in this log form is 2. So we're going to rewrite this as the base raised to the exponent is equal to the input of the log. So that's going to be 4 raised to the power of 2 is equal to the input of the log, which is x plus 3. Okay, step 1 is log form. Step 2, rewrite in exponential form. Okay. Step 3, solve for the variable. So we're going to solve for x. We want to get x by itself on one side. So the first thing that I see here is that I have 4 squared. 4 squared is 16. So I'm going to go ahead and simplify that before I start solving for x. I want to get x by itself on one side, so I'll subtract 3 from both sides, and I get 13 is equal to x. Step 4 is to check this answer in the original equation. So I'm going to go back up to the very original equation, and in place of x plus 3, I'm going to put 13. All I want to make sure of is that the input that goes inside the log, I want to make sure that that is greater than 0. As long as it's greater than 0, then our solution checks out. In fact, that amount turns out to be a positive 16. So we're good to go. So our final answer here that checks out is x is equal to 13. So log form, exponential form, solve for x, check that x value into the original equation, and make sure that the input is greater than 0. Alright, next equation. First thing I want to do is get this equation into log form. So I want to be able to look at it and say I have a log, I have a base, I have input of that log on one side, and I have exponent. Alright, so when I look here, I see a log ln that has a base of e, so it's log and base. I have the input, and I have equals, and I have 8 on the other side. The problem, though, is that this is not one of those things. The 4 that's in front of the log is not the log, it's not the base, it's not the input, it's not the exponent, and I need to get rid of that. Now, how do we actually get rid of that? Well, I can't just cross it out from the equation. So how do I get rid of this 4? Well, it's 4 times the natural log of 3x equals 8. In order to undo a multiplication, I'm going to divide. So I'm going to divide both sides by 4. So we end up with natural log of 3x is equal to 2. Now we are in log form. We have the log and the base, we have the input, we have equals, and then we have the exponent on the other side. So we have to make sure that we get into log form first, one log by itself on one side, that we see the base, we see the input, equals the exponent. Once we have those three things basically identified, then we can rewrite into exponential form. Alright, to rewrite in exponential form means we need the base raised to the exponent is equal to the input of the log. Okay, so we have to identify those three moving parts. The base, the input of the log, and the exponent. The base, remember when we see ln, the base is e. The input of the log here is 3x. The exponent is the number on the other side of the equal sign. So we have the base e raised to the exponent of 2 is equal to the input of the log, which is 3x. Step 3, solve for x. So we're going to take that equation and I'm going to divide both sides by 3. We want to get x by itself. And so I get e squared divided by 3 is equal to x. Now I do want to make sure that I check that solution in the original equation, and we'll do that here. We have 4 times the natural log of 3 times x is equal to 8. I put in there e squared divided by 3. To check our answer, I'm just going to simplify what's inside. 3 over 1 times e squared divided by 3. The 3's will cancel. What I'm left inside with is e squared. Alright, all I want to do is make sure that the input of this log is something that is greater than 0. E squared is greater than 0, so our solution checks out. Remember that you can check your answer in Desmos and find decimal approximations in Desmos. If we wanted to find a decimal approximation to our solution, we could do that very easily using a calculator. The answer we get here with the e squared divided by 3 equals x, that is what we call an exact solution. If I wanted to figure out an approximation, I'll just put it up here. I could put this into Desmos. This value is approximately, so I'm going to go to Desmos here, desmos.com. I'm going to click Start Graphing. I'm going to go down to the keyboard here, and I'm going to go to ABC, and I'm going to look for E, and I'm going to raise this to the exponent, let's say of 2, but let's say that I want to raise it to any old exponent. If I hit the A to the B power, that allows me to change the exponent to be whatever I want. Let's put in a 2. E squared is a positive 7.3. So that input turned out to be positive. If I want to divide that by 3, I'm going to come out of the exponent, so I'm going to hit an arrow that comes out of the exponent. I'm going to hit divided by, and then I'm going to hit 3. So I want my answer here to look like my answer on my paper. So our approximation for our final solution is 2.463 approximately. If I want to round, I can round to the nearest 2 decimal places. My math lab might ask you to round to the nearest 3 or the nearest 1. It kind of depends on your preference. So here I'm just going to round to the nearest 2 decimal places. I'm going to round to about 2.46. So the 3 would keep the number in front of it a 6. So 2.46 approximately. Okay. Alright. Our last solution, I really like this example. I think it's a good example for you to know how to do moving forward. The first step for these problems is to rewrite the equation into log form. So why are we not in log form right now? Well, remember that log form requires that you have 1 log, 1 base, 1 input equals 1 exponent. So we want exactly this form, and so the problem right now is that we don't have exactly that form because we have 2 logs. We have 2 logs, 2 inputs. This is not log form. In order to get into log form, we need to condense this. Now, what property can I use to condense? Well, if I'm adding in between the 2 logs, this is what we would call the product rule. So if I'm adding in between the 2 logs, that allows me to multiply the inputs together inside of a single log. So now we are actually in log form. We have 1 log, base 4. The input is now x plus 14 times x minus 1, and then our exponent is 2. Let's simplify a little bit more before we move forward. Let's actually FOIL this out. So I'm just going to write the word FOIL here so you can see what we're doing. First times first, x squared. Outer times the outer, minus x. Inner times the inner is a plus 14x. Last times the last is a minus 14. And if you wish, you could simplify a little bit more. I get x squared was at plus 13x minus 14. Okay, step 2 is to rewrite this in exponential form. So exponential form means I want to rewrite this as the base raised to the exponent is equal to the input of the log. Okay, the base of this is 4. The exponent is 2. The input of the log is now x squared plus 13x minus 14. Okay, so I like this problem because it requires that we kind of pull upon a lot of knowledge. We need to know how to FOIL. We need to know our product rule for condensing. we need to know exponential form. So it kind of requires that you know everything that we've been talking about up to this point. The next reason that I like this problem is because now we are required to know the zero product theorem. So we want to solve this by factoring ZPT. In order to do that, we need to get 0 by itself on one side, we need a factor, and then we need to use the theorem. So the first thing I'm going to do when I go to solve for x is I'm going to do 4 squared, which is 16. We'll just simplify that really quick. Okay, and I'm just going to pull this up here. Is now we need to get 0 by itself on one side of the equal sign. Okay, in order to do that, I need to get rid of the 16. So we'll say minus 16, minus 16. We end up getting 0 is equal to x squared plus 13x, and that's, what's that, minus 30? Alright, so we got the 0 by itself on one side. The next thing I want to do is find the product, which means I need to factor this. So you need to know how to factor a trinomial. So that would be x and x, so first times the first has to give me the first. My signs have to be opposite, so I'm trying to get this negative 30. My options for 30 are 3 and 10, we have 2 and 15, we have 5 and 6, 1 and 30, and I think that's it. So we want to be careful that we put our signs in first. If we do that, 3 and 10 doesn't work because the signs have to be opposite, but 2 and 15 will work with a positive 15 and a negative 2. So make sure you can FOIL that out and check it to make sure that it gives you exactly positive 13x and a negative 30. Okay, I'll leave the checking to you. Alright, so I'm just going to write this up here. We ended up with 0 equals x plus 15 and then x minus 2. Alright, and now, of course, our theorem says to set each one of those factors equal to 0 and then solve for x. So minus 15 on both sides, we get x equals negative 15. Plus 2 on both sides, we get x equals a positive 2. So again, I like this problem because you need to check your answers. And it's important that when you solve a log equation, you check your answers in original equation. Now we have two answers to check. We have x equals negative 15 and x equals 2. Let's check x equals negative 15 first. Now, where am I going to check this? Not in this equation, not in this equation, not in this equation. I'm going to go back up to the very original equation that I was given. So that means I need to plug it into log base 4 of x plus 14 plus log base 4 of x minus 1 equals 2. So in place of x in that original equation, I'm going to put a negative 15. So right away, we discover that we have a problem. I'm trying to make sure, my goal here in checking is to make sure that the input into these logs is something that is greater than 0. But negative 15 plus 14, that's negative 1. So that's a problem. That's not allowed. So that means that x equals negative 15 is actually not a true solution. So you will not type this answer into MyMathLab. Okay? If it makes your input into those logs, any log, if the input for any log comes out to be negative or 0, okay? Remember, our input has to be greater than 0. If it turns out to be negative or 0, then it is not allowed. It cannot, whatever x value that we have, cannot make any of those inputs turn out to be less than 0. Okay. Last one, let's check x equals 2. Okay, we're going to go back and check in the very original equation. So I'm just going to copy down everything except for x. And I'm going to plug in this time a positive 2. Okay, when we go to plug in a positive 2, all I want to check to make sure of is that the input into each log is something that is greater than 0. So 2 plus 14 gives me 16, that's positive. We're good to go. 2 minus 1, that's a positive 1. So it's positive, greater than 0, good to go. So x equals 2 is actually our only final solution. When I type my answer into my math lab, I'm only going to type in 2. I don't type in negative 15, and I don't mention that negative 15 doesn't work. You only type in the solutions that work into my math lab. Okay. So our final answer here that checks out is a positive 2.